Okay, so triangle proportionality theorem. This is on page 631. And this is going to show us another way to find the lengths of sides. So when a line parallel to one side of the triangle intersects the other two sides, how does it divide those sides? So it says, if we look at this triangle here, and it says when a line parallel to one side of the triangle intersects the other two sides. So I'm going to draw a line parallel to BC, and it intersects the other two sides. Okay, that's what they're talking about in that essential question. So now turn to 32, and right here is their picture, and it says here again, if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. And you can see right here, AE over EB equals AF over FC. And we worked with some of those triangles on those worksheets, and I said those were equal, but we didn't know why yet. Well, right here, and it all has to do with those two lines being parallel. And it's the same if you do it backwards, okay? If I know that AE over EB is equal to the proportion of AF over FC, then EF is parallel to BC. So this works backwards and forwards, this theorem does. So let's flip the page to 630. And I'm going to look down here. Okay, so if you look at this example on 633, it wants us to find the length of CY. So I'm going to put a little variable in there. And I know they've used X and Y, so I'm going to mark that. Whoops, they've used A too. Oh, excuse me. Okay, I'm going to mark it with an M. I'm going to call that M. All right, so I know that 9 is to 4, like 10 is to M. And if I do my cross multiplication, I get that CY is going to equal 40 over 9. Okay, and I'm not going to reduce that or anything, that's fine. So the second problem down here says find PN. And I'm going to label PN now with an X. Okay, so I know 5 is to 2 as X is to 3. So I get 15 equals 2X, or 15 halves equals X. And that's all there is to these. So I want you to do the next two on page 34. I want you to do these by yourselves and then check back in and see if you've done them correctly. All right, so for number 5, you should have gotten X equals 30, and for number 6, you should have gotten X equals 25 over 4. Now you can set these up either way. It doesn't matter. For instance, if I put 24 on the top, then as long as I put X on the top. And same here, I can put 5 on the top, but then I would have to put X on the top. And it will still work out fine. So the next page, page 635, we are going to look at example 4. So it wants us to verify that the line segments are parallel. And the only way I can do this is to prove that those two proportions are congruent. So I am going to say that 21 over 42 equals 15 over 30, which is 1/2 equals 1/2. And so that is true. And so I know that KL and MN are parallel. And that is all for this section. I will see you tomorrow.